Okay, I'm gonna start recording. Okay, we start with this working file as I explained previously about the stochastic transportation problem formulated as a two-stage linear programming. Okay, and we already show you the screen that we work on the Excel platform. Okay, so there'll be at first I need to oh so we so I think let me check if you can see the screen. Can you see the screen now?
Yeah, that's see.
This
The
is
screen.
yours, right? Okay,
Yes.
okay. This is your drive, right?
Yes.
Okay. I'm gonna upload. Okay. Or maybe the file is pretty large. I should send by
Or you put in your drive and I download from
yeah,
your drive.
okay. Uh, oh, it's not that large. It's only 8,000. Okay, let's try. Let's try and wash it a little bit. Okay, subloading. Hopefully not be able to use. So you can work on this, continue work on this later. Okay, we might come back to Excel first. Okay, you saw your Excel now, right?
Oh, I saw your Excel in my drive already.
Oh,
Two-stage transportation.
okay. So it's already it's already in, right? Complete already. Okay.
already come in.
Okay. Yeah. We're gonna continue work on this. Okay, and then I'll updating you the latest version before the end of the lecture. So we're gonna try to make this quite similar to what we did before on the previous two example of the investment model and the original classical one constraint LP that we show as the first example. Okay. Over here, okay, suppose I already I've tried to solve this problem by some heuristic of my own and by considering this. But before I can proceed, I need to erase all the randomness here, the formula of randomness here. Okay. So since this is a very, very large file, indeed, is generate. At this moment, there are uh, 10,240 scenario. Each scenario consists of 8 constraints. So it's already allow 80,000 constraint, right? 80,000 constraint, but uh, each the main variable there exists of 15 variable x of 1 up to x of 3 5. Okay, but certainly once you make a decision here and then you know the cost per unit that I show you on screen over here, right? You have a cost of transportation per unit. Suppose I just okay, let's try something else. I know that we have 3 warehouse. Okay, each warehouse is 50 plus 60 plus minus 10. Okay, so I'm gonna trying to and each customer demand is around 37.5 plus and minus 7.5. Okay, so I would know that suppose that for each okay, let's say x11, this is quite x13 is pretty cheap if you look at here. From warehouse number 1 to each customer, 3 and 4 is pretty cheap, right? And per unit, I mean the cost will be So I'm gonna try to but we still don't know the capacity for warehouse number one is at most it's gonna be 70, right? So I'm gonna try to say, okay, I'll put 30. Okay, let's say 30, and this one is 30 first. Okay, this is the decision that I make. Okay, let's try to focus on the value that we have. So this one is cheap for the 2 and 225. I know that 2 3 is but for customer 3 is already the requirement may be already fulfilled by the first warehouse, but the second warehouse, okay, you can see that 225 is also pretty cheap. Okay, so I'm going to put another 30 here for from 2 to 5. Okay, so that leave us no choice for the first two here. Okay, the first two I probably need 30 and 30 over here. Okay, well, that's the part. But if I make a solution by contribution, my solution like this is pretty conservative. That okay, for customer 3 and 4, I'm gonna put warehouse number 1 to take care of their demand. And for customer number 5, I'm using the second warehouse. And for the customer 1 and 2, okay, I'll use warehouse number 3 to take care. So and each around 30 something, but you know that the overall there might some demand that might they might exceed this. Okay, but you know that in advance that it's gonna exceed 70 for each part. Okay, so I'm gonna try to be like more conservative. Let's say I'm gonna use 35. Okay, as a way that 35, 35, and 35. Okay, so this is just a sample solution here, and
Mhm.
you know that the related cost. Okay, total cost. I use my evaluation cell here. Okay, the first part of the cost certainly I'm use equal, and then I'm going to use some product. Okay, of this one, the cost element over here, and then uh, do the sum product with the allocation cell. Okay. Okay. So initially, I know that now that is 945 unit cost. Okay, but there'll be some additional. I think certainly there will be some additional cost. What is the additional cost based on? Because there's some uncertainty of the element here. Okay. So therefore, for the left-hand side evaluation, okay, over here, I'm going to use this product we call sum product. Okay. I'm just use the sum product of the allocation cell over here. Allocation. And then I'll use function 4 f4 to fix the because our allocation always refer to this row, and then I'm going to do it with the coefficient on this generation. Okay, the coefficient down here. But yes, at this moment I think I can do this. Okay. Okay, but it's not looking very well, let's just say, because we still from scenario 1 scenario 2 we still have an uncertain element based on the simulation formula. So we only just want to keep the formula of uncertainty on this the one that I highlight you on at this moment on screen. Okay, and what we need over here is that we need to clear or to make this not the formula, to make this as an exact value. Okay, so one of the easiest way is that, okay, we have to, before we put on the formula here, okay, we just erase the formula, it doesn't work very well. Okay, we're gonna trying to make a copy and paste just all the value for each, what, okay, for all cell. Okay, that will be very fast. But the problem is that the formula over here also missing. You can see that from row 13 to row 20, we want to keep the formula, because suppose you want to add more scenario, you need to add this formula to the new scenario that you add on the cell. But from now on, from here, it's already fixed. You can see from scenario 1 to scenario 10,240, there's no more formula. Okay, no more formula. It's got to be all the scenario that you already generate. Okay, but this one you I need to re-input the formula again. Okay, you might say that why I don't pick just a part to make a copy to themselves, because it's a very large cell. Okay, so I just to make this re-input this again is much easier. Okay, so I just put the formula back again, that so this one is a generate by, if random value less than 0.8, it's going to be 1. If it's greater than 0.8, it's going to be 0. So this one is all. Okay, and you make a copy over here, you make paste over here, and then you copy paste. Okay, and then for this one, okay, you need to write the formula again. This one is equal to the first one. Okay, and this one equal to the second one, and this one equal to the third one, and this one equal to the fourth one, and this one equal to the fifth one. Okay, so you can see that, and also for this one is also we refer over here, equal here, this one equal to here, and this one equal to this one equal to this, and this one equal to this. And then for the third one is obviously equal to this one equal to this one equal to this one equal to this, and this one is equal to the last one. Okay, so you can see that this is a formula, right? But the last 5 constraints is have to refer to the scenario that they generate. Like in here, over here, you can see that there are only 4 available, 5 not available. So this one is available, but this one, no. Have to consistent with the scenario that you generate. But supply demand, certainly this is we already erased it, so we need to put back the formula again. Plus 50 plus integer of plus integer value of the random 20. Okay, so this one for 3 rows, and for each demand for each one is going to be 30 plus random integer value round down with this random number times 15. Okay, so this one is a generate the demand for each customer. So now all this is back to the original form, but the difference is that over here now no more formula, and since it's a very large cell, so I just place it this. So now we ready to go, we ready to work on. So the left hand side over here is that I can input this sum product of all. Suppose this is the allocation that we decide. I decide to allocate like this. Okay, and then I use function for, and then but now we check with the scenario each scenario. This is the scenario 1, the first constraint. Okay, so now you get this value. So you can see that now it become like the demand is only 61, right? But with this decision you ship the product out 70 units. You can see that in this problem we don't really know how much each customer want. You need to predict it. So there are possibility that the scenario that come out, you oversupply them. You ship the product out, but the demand doesn't meet. Just like people who sell the product for stock, right? In this case, the actual demand is only 61. Okay, but you ship it out from 35. Okay, and then I'm gonna evaluate the first scenario of the 8 constraint. Okay, this is it. So this is how it come out. Okay, uh, the first warehouse. Okay, you ship it out 70 unit. Okay, but the actual demand is only 61. But for the second warehouse, okay, you can see that here we allocate 25. Okay, but for the first scenario, the real demand is only 32. Okay, and the third unit, for each 35, but the real demand is much more. It's more than 38. This one 35, only 44. 39. You might see that why like the third unit over here that you really supply 70 unit, but why it didn't receive only 35? Because in the first scenario here, okay, you can see that for constraint 2, okay, x31 and x32, no, sorry, this one is okay. For this one, no, 2122, you can see that the scenario that one that generate, you can, since x25 the coefficient is 1, therefore this 35 is legitimate to supply. But for x31 here, okay, yeah, you get all 5. Okay, 1 2 3 4 5. Okay, but the problem is that 3132 you get 35, but from here, why you get only 35? Because why x1 4, why confusing? Oh, okay. This one is only 35 because there's only x25. Okay, but the real demand, okay, coming out no, it's okay, sorry. This one is you have 70, but actual capacity is only 61. Okay, so the first one is exceeding available capacity. The second one is okay, you send only 35, but you have 53 units. The third one is kind of our product. You said you're gonna ship 35, but you only have 32. No, sorry. This one, the third one is 70. You ship it down 70, but you only have 52, right? So you need a corrective action for these two. Like the first one, you need to ship for 9 more. This one you want to ship for you 18 more, right? Because you make a decision over here that you're gonna supply 35 units out of the first one. Okay, and but so from the first one, you 75 not enough, but for the second one you only ship 35. right? But the supply capacity you already have 53 for this situation, so it's okay for this one. But for the third one also, you want to ship it out 70, 35%, but you only have 52. Let's look at the first customer. The first customer demand is become in this scenario only 32, but you decide that you ship this product for him is uh, the first customer. Oh, the first customer only here. You can see that x11 is 0, x21 is 0, but x31 is 35. And also this in the coefficient for the scenario 1 of x31 is also 1 over here is so this 35 is valid. So this 35 coming to at the constraint number 4 here. Okay. You send 75, but the customer only need 32. The second customer need 38. Okay, but second customer X32 only supply 35, so can supply 35, which means that you can see that for each one, 3 receives 35, 4 receives 75, 5 receives 35, so 35 not 75. All of them receive, each of them receive 35 units. So this 35 unit is shipping to all customer. Okay, but you can see that with the uncertain demand for this situation, okay, for these 5 customer, you some of them you fulfill their need if it's more than like this one, but the other only the first customer fulfill the demand 32 because you ship it more, but the remaining 4 is lack of. So you can see that this is how we play. I'm gonna put this color of blue also, and also put this as a left hand side evaluation. And you can see that I can double click and then move it all, check in all possibility. Okay, based on all 10,240 scenario. Okay, so you can see that there's some way that your decision here fail. You see that, in this one, the scenario 10,000 to you have to make sure that sometimes this file might not, if you're working along with me now, you might get the different result because of the randomness, okay, effect. But no, there's no randomness effect anymore because now I already erase, use this as exact value. Yeah, you should get the same value as me. Okay, so this one is like evaluation of left hand side and right hand side. I only give you the observation of his that there's some time your decision fail completely. Like this is the 4th customer who need the product of 39 on scenario, the last scenario we generate of 10,240. But with your decision that you just make before this scenario, if this scenario happen, customer number 4 will not get any product directly. Because why? Look at the scenario that generate, because you can see that this is customer 1 2 3 0 here, customer number 4 no, 1 2 3 4, customer 4 no. For the third, this one for the second warehouse, for the third warehouse, 1 1 2, this one 1 2 3 4 5, 1 2 3 4. Oh, for already here is actually this one valid, and but this one had to be x24, which we based on our decision we already allocate x25. And the third constraint is that even though this is valid, it's x34, but you can see that x24 and x34 based on our decision up there in the first alternative, x24 is 0, x34 is 0. So this is how complicate the situation that when you bring in the uncertain situation, right? And once you make a decision here, this is all the x value. you have a high possibility that some constraint will be fulfilled and not fulfilled. And if you might remember that how do we handle this? We already we did it before that, like you remember the variable u and v that we used before. Okay, you don't have to worry about the value change on scenario 0 because we're not working on scenario 0 at all. So u and v. I just put u and v over here. Just use the same idea that okay. Where's uv is that we're gonna check if the left hand side is less than this is the right hand side, supply demand. Okay, if the left hand side less than the right hand side, there exists u. You remember the what we did, that we plus u minus v, right? Plus u happen when left hand side is less than the right hand side. You need to add value, add it up to make it equal. Minus v is that when left hand side is greater than the right hand side. If it's greater than the right hand side, so you need to reduce some value. So if u21 over here, this is less than t21 on this row, what you need is that there exists a u value. The u value will be, you use the value of t21 minus u21. Okay, unless you get 0. So this one is 0 definitely, because, and this one is if this one is greater than the left hand side, you just use the t21. Oh, why this one didn't work? Let's see. If u21 less than, oh no, oh, this is mistake, sorry. We just check that if this is left hand side, actually it says S/D is the right hand side. So if you check the left hand side, which has to be u21, if less than t21, okay, you get oh no, if have to be t21 less than u21, we use the difference between t u21 minus t21 unless 0. Okay. So this one you definitely you have 9. And at the same time, if t21 is greater than u21, maybe greater than or equal to u21, they might have some okay, we just well, just greater than u21. Okay, so we use the t21 minus u21 unless 0. Okay, so now you get this 0, and then and now you're now ready to work it on this. Okay, so now it quite becomes similar to what we did before, right? So you have 9. So this one is that since you ship it out 70, but oh, get confused. This is the right hand side, right? I should have known. Come on, man. What's happening to me? Okay, it's different. This should be V, right? And on the reverse, this is U, right? And you can check easily. Okay, check easily. How do you check? The left hand side, the that the equation is correct is that you use this left hand side plus U minus V. Okay, these two values should equal to each other. Okay, I'm gonna put some color here. Okay, this is a color. Okay, this is the okay, and then you can see that all of this have to be equal to this, right? Row by row until reaching the very final of this 43, 22. Okay, and with this variable of V and U, there's some associate cost per unit. Okay, based on in this one, you know now that we generate how many number of scenario. Maybe we just count this number of scenario. Okay. Number of scenario equal to. Okay. Actually, we're gonna use the link up to the last. The scenario that I count is over here. This value. Okay. So now you know that this is the number of scenario that we generate to solve this problem. Okay. Suppose we're gonna compute the average value. Okay, the average value of no, the average of U and V value. Okay, the average of for this one, we use the direct statistic like average of this one column, and then I move down to the very last. So this is V, right? And then I'm not using the average. I have to use the sum first. Some value of all the V value here divided by the number of scenario. This one. So this one will be the average. Yeah. Okay, let's just do this. But this one is not also very approximate. Suppose that if you have this is the average of not fulfilling the capacity that you have and also not fulfilling the demand. We assume that this is a 17 unit that is gonna on average, okay, for all scenario, okay. Average. Oh, okay. So we consider the sum of all V and then we divide here. And with this one, I think that we can, if we just fix the here, press F4 here for U10, we can find the average of U also. Okay. So the high possibility here that in this case, if you transporting like this 35 over here, on average, if you some in one scenario, the average of underachieve of the capacity and demand is 101 unit, but for the overachieve is only 17, right? Based on this allocation. Okay, and you can see we use the cost per unit of this unfulfilled. Okay, maybe the opportunity cost or the uh, collective action cost over here, right? Okay, suppose we add this for the original one, you have 945. Okay, suppose the additional cost over here is that if you okay, I'm gonna do like this one for V can be 25 unit per okay. It's just assume, but in reality, you need to have the assessment of this value from your accounting department. For 101 over here, maybe I put 20, okay, maybe 20. Well, it's okay. 25 and 20, okay, and with this is a contribution for this total cost. This total cost, okay, we since we make a copy, I will say that the formula is gone, so we need to re-input the formula again. This is a sum product of this allocation with the cost associated cost for each uh, allocation from each warehouse to each customer. Okay, and then plus this one additional of collective action cost. Okay, like this one, the first one is cost per unit here times the average here, and then plus cost per unit over here times over here. Maybe a little bit too much. I just change this to become not so much. Maybe I put this as a 10, and this one maybe uh, let's say let's assume this 5 and 3. Okay, let's say only 5 and 3 unit here to make. You might wonder why I change the value of this. I just because in reality, when you apply this for the real situation, the major cost should be still maintained within this. So this is the majority of the cost, which is exactly. This is the exact cost that you need to pay. But for this one is this one, the additional cost of U and V here. Okay, with cost per unit over here. This is the expected value of V and U and time cost per unit. This one is more like what we call the probabilistic cost, and it's not you don't know this cost until the real situation happen. So in this one, just like the investment problem, right? You investment problem even worse. You don't even know the return until the real market profit or benefit or loss happen. But you need to make decision before that how you're going to invest. The same here. You have to make the decision how to transport and send it when you're not knowing the real demand for each customer size, and also you don't really know the situation of the real capacity that's going to happen. You only have some experience the data with risky data with some certain possible alternative that can happen. So this is the way that we if you now if I save this again, okay, I can put this on it's going back to become like a previous the very first piece of work that you did. Okay, you remember that? You remember the first one that you did? You have x1 to x6, right? Only 6 variable first, and then but now you have 15 variable over here. You need to find the allocation here. Your target cell is over here. This is your target cell, 1300, and this is your decision variable is over here. Okay. If you want to use the origin open solver, you can say that this is also your uh, changing cell. Okay, so I'm gonna put this, and maybe I put this color in the yellow color similar to the previous one, and then I can do this again, so that this is a the shaded yellow shaded is all decision variable. Okay, so this one is your changing cell. I mean, if you go back to the very first assignment, you can use open solver to solve this one.
Okay.
Okay, but the problem is that in this case the problem going to be much larger than the previous one, because now you ending up having more than 80,000 rows, right? And then we're not sure how open solver gonna respond it. But let's just say that it's exactly the same as this the your first assignment here over here, right?
Maybe
Maybe this is what you did over here.
homework one.
Yeah,
Yes.
homework one. Yeah, this one. Take a while. Oh, this is a large. No, we can wait until. So if you're familiar that and now is the situation is exactly the same as where we all start, right? You remember that?
Yeah.
Okay. So the very obvious assignment is that you can either use open solver to solve this problem again, or the second alternative is that just like what you did in the first uh, test, we wait. It's not coming out yet. From your first assignment is that there are three platforms that you can do: the open
Yes.
solver, or you can use Blender under Excel platform.
Have
Yeah,
both LP and Blender and MATLAB also.
yeah, and also you can use this apply to the MATLAB. Okay, so that's the start for this assignment. This is going to be the last assignment set of the assignment. And next week, okay, with your certain progress, we're gonna integrate the uncertainty of this one, the cost here. You remember the cost uncertainty? Suppose that it becomes 5 plus minus something, 6 plus minus something. Suppose you have the uncertain element here of the cost per unit, and then you might use the second set after the multi-objective investment model. Remember that suppose you have cost, the target cost around this, then we're gonna another UV. This is a UV variable that we use only to check the uncertain after you make a decision that you have a risky situation that you're gonna meet the demand of each customer, or you're gonna be able to have enough available capacity. Okay, so now in this assignment only UV for this, but you remember that if the cost over here is uncertain, 564 is uncertain, you need another UV to handle the target of the cost also. Okay, so this is the platform of problem that we're going to integrate the previous two big assignment to just one sheet to work on. Okay, and so it's the start of the last assignment, let's just say like that. Okay.
Yeah, really large.
uh, but as you know that the under Excel situation, you sometimes you have a difficult time to handle the very large worksheet unless that you go to YouTube and study more about big data. You just type big data on using YouTube. No, not using big data for Excel. So
Okay.
there might be some integration with Python. With I saw recently that many people trying to work on the big data platform using Excel. But if you use the regular Excel, it's gonna face the problem at one point. But we already illustrate the MATLAB application that can extend your capacity to solve that. Yeah. But for the visualization or illustration, the basic concept, the problem, Excel still a better tool to show you. So I just start with the Excel over here. Okay. So your homework from start from this one is that okay, now you can use the open solver platform, right?
Yeah.
You remember open solver? Yeah, this is your target cell. Your
Okay.
changing cell is this one, x1 to x15. And also changing cell, the second set is all the UV over here. Okay, all the UV. And your constraint is only this check column for every row. Okay, this check have to be equal to this one, the right hand side of scenario, excluding scenario 0. Start with a scenario 1 to scenario 10,240. Okay.
Okay.
So you might try if your open solver under your machine is capable to solve this problem. And also, but again, this one is already set with the good uh, start if you apply what you did previously with this worksheet. Okay, that you using this one you using the direct MATLAB and here and uh, you can see that after this one you still be able to use the open solver, right? This one you still using open solver, I think.
It can work.
Did you use or in this situation that you saw on the screen, did you use open solver or you use Blender?
Open solver.
Right, yeah, open solver I see. So the open solver resource. This one is still open solver. Oh, this one, all of these are using open solver, right?
Yes.
Okay, so that's it. So now you can if you understand this, now you can apply uh similar concept here to this problem, right? One, you using this to solve using open solver, and the other way around, you can convert this data and implement with MATLAB and make a comparison study. And then the third alternative is that you before you go directly to MATLAB, you can still work Blender decomposition under Excel platform. Okay.
Okay.
Okay. So this one is a repeat of the previous one, but it's a start because, as I told you, that we got integrate the second type, the second homework of the investment model. When the uncertain cost coefficient, we're gonna apply to this one or to the previous two collected in one using transportation as a vehicle to illustrate the concept. Okay,
Okay.
so probably we should meet next week. Probably the last time that we gonna show you that both Excel and MATLAB platform and vendor decomposition when the tools to all uncertainty are integrated to just one problem.
Okay.
Okay,
Okay.
is that clear? Okay, so you you have any question to make a progress of the work? Probably not.
Yes,
Okay,
maybe
I save this file for you, and then
but actually อาจารย์ลองดาวน์โหลดในไดรฟ์ของหนูอะมันดูได้แค่ออนไลน์ มันดาวน์โหลดมาไม่ลงเครื่องหนูอะไม่รู้เป็นเพราะไม่งั้นอาจารย์เอาไว้ไดรฟ์ของอาจารย์นะมี
Oh, okay. I'm gonna send it to Messenger แล้วกันนะ เดี๋ยวลองดูว่าส่ง
ใช่
Messenger แล้วเป็นไง เดี๋ยวลอง
พยายาม
เดี๋ยว
โหล
ลอ
ด
ง
มันไม่ออกมาเลย
เดี๋ยวมี Facebook we use Messenger here okay เดี๋ยวลองส่ง Messenger ให้คุณนะI'm not sure the file is too large or not. It's gonna be this one. It's on the desktop. The file is this one to slash. I'm gonna use the recent one. I'm gonna save it again. นะ Take a while. Okay. And then เดี๋ยวลองดู save นะครับ Okay, let's just okay. So yeah. We attach a file for you. Let's try this. Hopefully not. Huh?
maybe
ได้ไหม Did you get on Messenger?
I get it already but I try to download first โอเคค่ะ it's work complete
Okay. So now you can go ahead and get started with. But this one you can't open this, right?
open already
Okay. Okay. All set. Okay. Move on, and then next week.
This one is a new problem that never teach in the last session before.
Well, actually use the old concept.
Old concept, but
They use the old concept with the new problem.
Question.
Just show you that the old based on that example, you can keep extending to solve several problem.
Okay.
Okay. So I think next week we if you possible we meet at the office, okay, for last time to set up all the remaining work that you need to submit, okay, before I finish the course and then submit the grade for you. Okay?
But it may be after the เกษตร fair, right? After 10.
Yeah, but yeah, after have to be after 10 next week. It have to be next week.
Okay.
So next week, just give me that what time that you be available to come to the. Okay.
Okay.
And then okay.
Step.
ก็
ได้ค่ะ
okay.
Great. Yeah, will progress you between your week.
Okay. Great. Let's keep it up. Okay.
ค่ะขอบคุณ
Okay นะ Okay. Thank you. ไว้ see you.
ค่ะสวัสดีค่ะ